Hey everyone. Alright, today we are going to learn about simple event probability. Your objective: I will be able to find the probabilities of simple events and their complements. Alright, so a simple event is an event that has one outcome or a collection of outcomes. The important thing to know about a simple event is that there is only one action that takes place. So some examples of simple events would be like flipping a coin and it lands on tails. That's one action that takes place. You just flip the coin. If you roll a die, that's one action that takes place. So that is a simple event. Now, probability is the likelihood that an event will occur. We are going to represent probability as fractions, and we are also going to describe probability. Now, if something cannot happen, if it is impossible, that would be a 0% probability. So something that would be impossible is landing on a 7 if you roll a typical die. There's no number 7 on there. It's impossible. There's a 0% chance that would happen. So then we move to unlikely. Unlikely means it can happen, but there's not a great chance that it's going to. So that would be like rolling a 1 on a number cube. Only one side has that on there, so it's not likely it's going to do that. As likely to happen as not means it is equally likely. So if I said odds versus evens on a die, it's just as likely to land on an odd number as it is to land on an even number. So likely means it will most likely happen. So that would be like saying what's the probability of rolling a number greater than 1 on a die. And we have 2, 3, 4, 5, and 6. So there are obviously way more of those. And then it will definitely happen. There is a 100% chance. That could be like flipping a coin and saying, you know what, it's either going to land on heads or tails. Well, yes, that one of those will happen. There is a 100% chance that is going to occur. All right, whenever we actually find probability, we are going to take the number of wanted outcomes and we're going to put it over the number of possible outcomes. Think of the number of possible outcomes as the total number of outcomes. All right, so let's go ahead and do some examples together. So in example 1, we are going to find the probabilities and describe the likeliness of each one. So you are rolling a number cube. So that's a normal like die that's labeled 1 through 6. And we want to find the probability of 4. Whenever you see this P, that means the probability. So you'll see a capital P and then you'll see something in parentheses, and that's what you're trying to find the probability of. So we are trying to find the probability of rolling a 4 on a typical number cube. We'll get to those in a minute. So there is one side of the die that has a 4 on it, and there are 6 total sides. So the probability would be 1/6. Now, since only one side has that number on it, the probability of rolling a 4 on the very first try is unlikely. Yes, it can happen, but it's not likely to. All right, now we want to find the probability of rolling a 5 or a 6. Okay, so a 5 or a 6, there are 2 sides that could have either one of those numbers, because there's a side with a 5 and a side with a 6. And then there are 6 total sides. Now, as always, if we can simplify, we will simplify. So 2 over 6 reduces to 1/3. So there is a 1 in 3 chance. So that's still unlikely that on the first try it would land on one of those. Another thing to think about with unlikely is there's less than half of a chance. So half of 3 would be 1.5. 1 is less than that. It's less than half of a chance, so it's unlikely to roll one of those on your first try. All right, now find the probability of 7. All right, well, is there a number 7 on a typical die? No, there is not. So there are 0 sides out of 6 total. So that's just 0. So this one is impossible. And find the probability of rolling a 1, 2, 3, 4, 5, or 6 Okay, well, there are 6 sides that contain those numbers out of 6 total. 6 over 6 equals 1 whole. There is a 100% chance, is what this is saying. So this will definitely happen. So we would describe that as definitely will occur. All right, complementary events are 2 events in which either one or the other must happen, but they cannot happen at the same time. So this is basically saying if you find the probability of one thing, you can find the probability of it not happening, but those 2 things are going to sum to 1. So think of the complement as the probability of something not happening. All right, let me try that again. There we go. So we have the probability of the event plus the probability of it not happening, and that is going to equal 1. So let's do an example and actually see how that works out. So we're going to determine the probability of rolling a 6 and not rolling a 6 from example 1. So remember, we're just talking about a typical 6-sided die. And then we're going to describe the relationship between the two. So we want the probability of rolling a 6. Well, there is one side that contains the 6 dots out of 6 total sides on the die. So the probability of rolling it is 1/6. Now the probability of not rolling a 6, well, there are 5 sides that do not contain 6 out of 6 total. Now if you notice, if we were to add these fractions together, remember when we add fractions we don't add the denominators, but we do add the numerators, we would get 6 over 6, and that equals 1. So the probability of something happening plus the probability of it not happening will always sum to 1. So the probability plus the complement equals 1. Okay, now it is time for you to try. So you're going to find the probability of rolling a 2, 3, or a 4 on a number cube. Describe how likely it is for that to happen, and then list the complement to this event. And keep in mind, your probability and complement should sum to 1. All right, make sure you bring your notes with you to class, and have a good day.